Numbers are everywhere. We use them to count, measure, and calculate. But did you know that numbers have evolved over thousands of years? From ancient tally marks to the numbers we use today, their journey is full of discoveries and breakthroughs. So, let's dive deep into the history, classification, and future of numbers. Long before written language, humans needed a way to count. The earliest system? Tally marks. Archaeologists found the Ishango Bone from 20,000 BCE, showing tally marks used for tracking days or trade. Babylonians developed the base 60 system. That's why we have 60 minutes in an hour and 360 degrees in a circle. Egyptians used hieroglyphic numerals for trade, construction, and fractions. Chinese created an early decimal system and the abacus. Pythagoras discovered irrational numbers, challenging the idea that all numbers are fractions. Romans used Roman numerals, but without zero, calculations were difficult. The concept of zero and place value system was introduced by Brahmagupta in India. Islamic scholars like Al-Khwarizmi spread the Hindu-Arabic numeral system, the foundation of modern numbers. Fibonacci promoted decimal fractions and Hindu-Arabic numerals, replacing Roman numerals in Europe. In the modern era, binary numbers, just zeros and ones, power our entire digital world. Let us now explore the number system and its classification. We'll give you the name of the number system, the symbol used, and the numbers which belongs to that set of number systems. So let's begin with natural numbers, n. These are the counting numbers 1, 2, 3, 4, and so on. 0 is not included in this, but if we include 0, it becomes a set of whole numbers, w. It includes 0, 1, 2, 3, and so on. Now it comes to integers, which also includes the negative numbers. So from 0, we had been going right, 0, 1, 2, 3, and so on, which is the set of whole numbers. And if you go left, it is -1, -2, -3, and so on. So that becomes set of integers, which includes negative and positive numbers. As you see in temperatures, daily life, right? They go below 0. Debt, money borrowed, or depth below sea level are all negative numbers. Now, what happens when I divide a negative number by another number? It could be negative or positive. Whenever you divide two numbers, you get something which is not an integer. We need to expand it further. So the number system expands to the set of rational numbers represented by letter Q. So rational numbers are fractions of the form P over Q, where Q cannot be equal to 0, since you cannot divide by 0. Makes sense. Well, just when we thought the number system is complete, we came across many other numbers. For example, square root 2. If sides of the square are 1 and 1, the diagonal is going to be square root 2. Now, square root 2 cannot be written in the form P over Q, and therefore we need to further expand our number system. So that included the real numbers. There were many other numbers like square root 2, which we now call irrational numbers like pi, e, and many others. So all these numbers will now be included into the set of real numbers. So real numbers represented by letter R includes the rational numbers and irrational numbers. This covers our number line. However, there are still some exceptions. While solving quadratic equations, you come across x squared plus 1 equals to 0. That means x squared is negative 1. How do I get square of a number as negative 1? Since in real numbers, squares are always positive. So we need to expand it further to a set of complex numbers. Complex numbers gave us the letter I, iota. Now, I is basically equal to square root of negative 1, or you can say square of I is negative 1. Equation x squared plus 1 equals to 0 has no solutions in the real world with the real numbers. But with this iota, I, the set of complex numbers, now we have a solution. So, what if discriminant is negative? If the discriminant in a quadratic equation is negative, means b squared minus 4ac is less than 0. The equation has two complex conjugate roots. Beyond complex numbers, we have quaternions, octonions, and hypercomplex numbers, which are used in quantum mechanics and computer simulations. Here are 4 questions on the number systems quiz. Question number 1. Is square root 2 a complex number? Question number 2. What is cube of complex number I? Means I need you to tell me what is I cube equals to. Question number 3. Number line represents all real numbers. How do you represent a complex number? And question number 4 here is infinity a real number? Answer these questions at the end of this video. I am going to provide solution to these answers. Let's move on. Today, we discovered how numbers evolved and how complex numbers help solve problems that real numbers cannot. Here's what we learned. Numbers evolved over centuries, from tally marks to binary code. The number system is structured. Each type of number has a purpose. Complex numbers extend beyond real numbers, solving quadratic equations with negative discriminants. Real numbers are represented on a number line, but complex numbers need a plane. Mathematics is full of surprises. Numbers are not just calculations. They shape science, technology, and the world around us. Keep exploring, keep questioning, and keep learning. Want to dive deeper into numbers and sharpen your problem-solving skills? My book, Crack the Numbers for Future STEM Leaders, is designed for students like you who love mathematics and want to go beyond the school curriculum. Step-by-step explanations of number systems and operations, challenging questions, and STEM-based applications, real-world connections to science, engineering, and technology, QR codes linking to exclusive video lessons for deeper learning. Click the link in the description or scan the QR code to explore a whole new way of learning math. Mathematics is not just about solving problems. It's about discovering patterns, making connections, and unlocking the future. Let's continue this journey together. As promised, here are solutions to the questions asked earlier. Is square root 2 a complex number? Indeed, it is. Every real number is also a complex number. What is cube of complex number I? I cube can be written as I squared times I. I squared is minus 1, so minus 1 times I will give me minus I. Question 3. Number line represents all real numbers. How do you represent complex numbers? Complex numbers need a plane. So along the x-axis, you put the real numbers, along the y, the complex numbers. It is called argand or complex plane. Is infinity a real number? Not at all. We can approach infinity, but we cannot be there. It is not a real number. Thank you. Scan the QR code to explore a whole new way of learning math. Mathematics is not just about solving problems. It's about discovering patterns, making connections, and unlocking the future. Let's continue this journey together.